Chapter 6, Section 7. In this section, we're going to learn the following objectives: determine the future value of a lump sum of money and calculate effective rates of return, determine the present value of a lump sum of money, and then determine the rate of interest or the time required to double a lump sum of money. So now let's look at the first topic: determine the future value of a lump sum of money. So before we look at the example, we're going to introduce a formula first. If a principal, we use P to represent P dollars, is borrowed for a period of time, and then time use T to represent in the unit of years, at a per annual interest rate R, expressed as decimal number, and then the interest I can be calculated by this formula. I equals P times R times T. Again, I represent the interest earned for the investment. P represent the principal, which is initial money you deposit in the investment account, and then R represent interest rate. That's normally a percent number, and then T is the time of your investment. The unit must be in years. So I equals P times R times T. All right, now let's look at the example. A credit union pays interest of 2% per annum, compounded quarterly, on a certain saving plan. If $1,000 is deposited in such a plan and the interest is left to accumulate, the question asks you how much is in the account after 1 year. So let's first identify some of the parameter. So $1,000 is deposited into that plan. So principal equals 1,000. And this credit union account pays interest 2%. So interest rate, that's 2%, which is convert to decimal, that's 0.02. And then if the interest is compounded quarterly, so that means 1 year, there are 4 quarters, right? 4 quarters in a year. And we know the interest is not, withdrawn, right? It will be keep in the account and then to accumulating the more interest. And then we want to know after 1 year how much in this account. So in order to find a 1 year, how much money in this account, we actually have to do it quarterly because interest compounded quarterly. So in the first quarter, how much interest we made? We use the formula introduced in the previous slides. Interest I equals P times R times T, right? Principal times the rate times the time. But this time must be in the unit of years. Be careful. So we plug it in. Principal is 1,000 times interest rate is 0.02, and times T, we talk about the quarter, right? Every quarter the interest compounded. So 1 quarter is 1 out of 4 of a year. 1/4 of a year, right? Because 1 year have a 4 quarter. So that will calculate at the first quarter how much interest we made. So if you use your calculator, and then we got a $5. So we make $5 as the interest. So $5 will leave in the account, right? So in the second quarter, and how much is the principal? Is no longer 1,000. Now it's 1,005, right? That's $1,000 plus 5. That's the interest made from the first quarter. And then same thing, multiply by the interest rate, multiply by the time is another quarter, right? Second quarter. So If you calculate it, we make $5.03 as the interest. Okay, and then we do the same for the third quarter. So now we have 1,005, right, in the previous 1,000 plus 5, and then plus 5.03 times 0.02 times 1/4, and then you got $5.05 as the interest. Okay, and of course you can, just combine those. Okay, I write it out just for you to see where those numbers coming from. And then the last quarter find is initial principal plus first quarter interest made plus second quarter interest made plus third quarter interest made, right? There's a first quarter, second quarter, third quarter interest made. Now we calculate it at the end of the fourth quarter, which is a year, how much money in the account, right? How much interest we made. So that will be 5.08. Okay, that's the fourth quarter, how much interest made. So how much in the account balance? Okay, I don't have a space, so I write on the top. Okay, account balance will be 1,000 plus 5, that's first quarter interest made, plus 5.03, second quarter interest made, plus 5.05, third quarter interest made, plus $5.08, the last quarter interest made. So that will give us the account balance, which is $1,020.16. Okay, so this is the answer we're looking for. All right, that's how we computing the account balance after interest compounding quarterly. So that's the book solution. Okay, you can go through it. That's exactly the same process as what we just did.